In this video, I will show you how to write the inverse of a function. Let's take the first example here. We have f of x equals 2x plus 9. Let's go back to the definition of a function where you have inputs and outputs. So in this table, the inputs are negative 3, 4, and 10. And the outputs are 3, 17, and 29, respectively. So when I substituted negative 3, I doubled the value and then added 9. When I substituted 4 into there, 2 times 4 and then add 9 gave us 17, and so on and so forth. So what the inverse does, and you'll notice that the notation is different, it has that negative 1 as kind of an exponent, even though it's not an exponent in the sense that we think about. That just indicates we have an inverse. What the inverse does is it takes what was an output for f of x, and then it's going to pop out what was the input for f of x. So in other words, the input and output get switched, as you can see in the table here. So negative 3, which was an output previously, when we substitute that into our inverse, out pops out a negative 3 output. The input is 17, we get 4, and then the input is 29, and the output is 10. So you notice here that the x and y values switch. Okay, and so that's basically the definition of an inverse of a function is it undoes what f of x does. Okay, now how do you write the equation though quickly for an inverse? And there's several methods. One of the fastest ways is to really focus on the idea of operations. You'll notice here in part A, f of x is, when we substitute something in, we double it, then add 9. So what the inverse is going to do is it says, I'm going to do everything the opposite way. So in other words, if we multiply by 2 and then we add 9, then it's going to subtract 9 and divide by 2. So let me show you the method by which we do this, which I call the table method. So I make a table where I'm listing the operations and the orders by which the operations happen. So for f of x in our original equation, according to this, when I substitute something in there, we multiply by 2, and then we add 9. So the inverse says I'm going to do everything in the opposite order, and then the inverse operation. So in other words, what we're going to do first is subtract 9. Okay, so it's the inverse operation of adding. And then, instead of multiply by 2, we're going to divide by 2. And that's going to be our last step. So therefore, the inverse is, and so I write an x, and then I start going through my list of operations to fill in the rest of the equations. So when I have some input in my inverse, I'm going to first subtract 9. And then to all of that, to all of what I just did there, then I'm going to divide by 2. So let's verify that that works. Looking back at our table here, when I substitute 3 into this equation here, so 3 minus 9, that makes negative 6, and then I divide by 2, boom, that gives us negative 3. Let's try 29. 29 minus 9 is 20, divided by 2 makes 10. Boom, we found the equation where it takes the outputs that were of f of x, makes them the inputs, and then out pops out what we had originally as an input a long time ago. Okay, second example. So this time we have a quadratic, we have a restricted domain. This would be a case where the inverse wouldn't be a function, and we'll go into that at another time. Okay, first let's list our steps of what we do when we have an input into f of x. So the first thing that we do when we substitute a value into f of x is we square. Okay. Step 2, now a lot of people would say you multiply by 5/7, and you're right. I think it's helpful if we see multiplying by a fraction as 2 different steps. So I see it as multiply by 5, and then the third step is divide by 7. So then the inverse does all of these steps in the opposite order using inverse operations. So in other words, step 1 has nothing to do with square, we just do everything in the opposite order. Instead of divide by 7, I multiply by 7. Step 2, I divide by 5. And then the last step is we square root. So then my inverse function is I have x, and I kind of write x kind of off a little bit to give me some space in case I need to put stuff in front of x. So to this input, I first, okay, step 1, multiply by 7. I like to say the phrase to all of that in my head or out loud sometimes, and I kind of circle, kind of motion around what I'm doing. So to all of that, I divide by 5. And then to all of that, I square root 7. And if we made a table of values that worked for f of x, and then we switched them for x and y for the inverse, we would find that it actually works out. But this undoes whatever f of x does. Okay, the next example. Let's list what f of x does. So step 1, as you see here, kind of thinking order of operations. If I substitute something for x, I first add 9. And then we have cubing. We cube the value. So the inverse, we'll take all of these and do the inverse operations in the opposite order. Okay, so step 1 is to cube root this time. Step 2 is to subtract 9. Therefore, the inverse function is, so I write x, leave a little space just in case I need to put something in front. Okay, so to all of this, to every input, I first cube root. And I'm just going to kind of circle motion. To all of that, I subtract 9. Okay, last example here, letter D. We'll list the operations that we see that f of x does to the input. Okay, so if I were to substitute 10 or 100 or -2 or whatever, first thing we're going to do is multiply by -6. Key thing here is, do note that yes, it's a negative, but we're not subtracting 6. What's the operation that's happening between x and this -6? We are multiplying. So I'm multiplying by -6. Okay, step 2, we are adding 8. Step 3, dividing by 5. So the inverse then does all of these steps, but in the opposite order using inverse operations. Okay, so step 1 is to multiply by 5. Step 2, subtract 8. Step 3, divide by -6. So the inverse function is, okay, I'll take x, that'll represent any inputs I put in there. So x, and I first multiply by 5. Then I subtract 8 to all of that, and then to all of that, divide by -6.